Hi everyone, as my entry into the Maker's Rock album Art Collab, I've built the cover of Judas Priest Painkiller album. In fact, this is not just an art piece, but it's an Arduino-controlled light show that reacts to music. I will be giving it away, so stick around to find out what it can do, how I'll build it, and how you can win it. I've built the frame out of some pallet boards that I've salvaged. I marked 4 pieces of the clean parts of the boards that measured 30 cm in length, making sure to mark 45 degrees miters for the joints. I did all of the cutting using my jigsaw and it worked okay. If you have access to a miter saw or a table saw, then you can use those and get much better results. The joints were not perfect, but with my belt sander I was able to get the pieces to fit nicely. During the test fit, I realized that they are too wide and that they will take a lot of space in the inside of the enclosure, so I decided to cut them to 2 cm in width. Again, I used my jigsaw, making sure not to cut inside the line. The miter joints did not have a lot of support on their own, so I've cut small triangle pieces to glue in the corners as some extra support. I'm sure that there are a ton of better options to do here, but this was the best idea I had in the moment. I joined the miters with wood glue in the middle of the joints and CA glue at the ends in order to act as a clamp and hold it in place while the wood glue cures. The little support triangles were glued into place using only CA glue in order to make the process faster. The electronics for the light show inside consist of an Arduino Uno board with a microphone from a broken headset that listens for the sound in the room, and then it reflects the total sound volume by lighting one of the 5 pieces of LED strip inside. The circuit is made out of 2 independent parts. The first part is the microphone with its single transistor amplifier, while the second part are the drivers for the LED strips. We need them since the Arduino and the microphone amplifier work on 5V while the LED strip runs on 12V. The microphone is connected to the 5V output of the Arduino through a 10K resistor and through a capacitor to the base of the transistor. The transistor then amplifies the signal with a mid-level of 2.5V so we can pick it up on the analog input A0 on the Arduino. In order to turn on the 12V for the LEDs, the base of the transistor is connected to a digital output through a 10K resistor, and the same circuit is repeated 5 times. I'm turning on just 3 LEDs in each of the sections, so I'm able to get away using the transistors. If you would like to modify the project to use longer strips, then you will need to use some MOSFETs. Although it might seem as a complicated circuit, it's really a very simple one. I've tested it all on a breadboard, and after I made sure it works as expected, I've built a shield to be mounted directly onto the Arduino Uno. While you watch me build the shield, let me remind you to subscribe to my channel if you are new here and to also check my social media pages. I build various projects with all sorts of electronics and code, so I can promise you to keep you entertained. I run this channel as a personal hobby, and if you learned something, then please consider supporting my work on Patreon or through a one-time donation on PayPal. All of the support links are provided in the video description. The main star of the project is the code that is programmed onto the Arduino. This is what does the heavy lifting of analyzing the sound levels from the microphone and turning them into visible light that follows the music. You can download the entire code from a GitHub page, and you can find the link to it in the video description, along with the schematics for the electronics. In a nutshell, the code has 3 main parts: retrieving a sample of music to analyze, determining the sound levels and then controlling the outputs to the LEDs based on the calculated value. I know that this might sound like rocket science to some, but it's really very easy once you get hold of things. The sketch at the beginning defines all of the variables and constants that we're going to use. I made sure to provide an explanation to each of them so you can understand it more easily. After that, we will have the setup function that starts the serial communication for debugging purposes, empties out and initializes the array we're going to use for the peak-to-peak volume detection, and defines the output for the LEDs. In the loop section of the code, we first start the sampling of the audio so we can detect its peak-to-peak volume. In a regular sound wave, the absence of any noise is a level at the midpoint of the minimum and maximum voltage the amplifier can produce. In our case, that is 2.5 volts. Once a sound is detected, we get a wave that moves up and down, so to detect high noises, we are interested in the combined amplitude in that wave. So, instead of a moving wave, we map the values from 0 to max in a sort of inverted state to easily distinguish high from low volume sounds. The next two sections of the code do exactly that. First off, we measure the peak-to-peak amplitude, and then we determine the maximum of that peak for the period. The way the microphone works, the further you are from it, the less volume it can pick, so we need to calculate a factor that will either amplify or decrease the measured signal and have the same reaction on the different levels. As a final step, we multiply the measured value from the microphone with the factor that we just calculated, and based on the result, we turn on specific LEDs. After the board was all soldered as per the schematic, I made sure to test it before proceeding on preparing the actual album art. For the front of the piece, I've used a sheet of clear acrylic. I've cut the printed artwork to dimensions and applied a layer of transparent wood glue to the surface without the protective cover on the acrylic. If you have access to Mod Podge or to some clear acrylic gel medium, then it is better to use that instead of the wood glue, but it works almost the same. The trick while applying the image is not to use too much wood glue as I did, in order not to get wrinkles on the paper. Less is better in this case, but the surface must be fully covered. With the glue still wet, the artwork is barely visible, but after it fully dries, it will turn transparent. I left the frame to cure for 24 hours and then I figure out the placement of the Arduino inside the frame. I want the art piece to be hanging on a wall, and since it needs to be plugged in for power, I've mounted the board on the bottom side so the power adapter will come up from the wall socket. I used a hacksaw to remove most of the material and then worked my way through with a chisel and a file. If you have a hand router, then that will be a lot faster than the chisel. I also drilled a hole through the frame so the microphone can stick out and pick up the sounds from the room. Before finishing, I've sanded the frame up to 240 grit sandpaper and then applied a coat of wood stain lacquer. I used a piece of cloth to wipe the stain on and then wipe it off after some time. The thickness of the frame was not enough to hold all of the electronics in place, so I've cut and glued 2 layers of 5mm black XPS foam insulation to both sides of the frame. Aside from making room for all of the electronics, the foam gave the piece a nice layered look from the sides. All of the electronic components are mounted inside the frame using hot glue, starting from the microphone and then the main Arduino board. On the back, I've marked and cut a sheet of 3mm high-density fiberboard that will act as a backer board and a reflector since one of the sides is white. I've used small 3.5 by 16mm screws to attach it from the back. I then remove the backing from the glue on the LED strips and stick them onto the fiberboard. The acrylic front is also attached with the same 16mm screws, but I countersink the screw holes with the 6mm drill bit in order for them to sit flush with the front. If you have a router, then you can make a groove in the frame and enclose the acrylic that way. At the end, it was just a matter of removing the other protective layer from the acrylic sheet and testing it all out to make sure that it was still functional. To hang it on the wall, I've added a piece of string between 2 of the screws on the back. All in all, I'm super pleased on how this turned out. The enclosure could have been a bit better if I had the proper woodworking tools, but it's still a nice wall decor. Since I built it, we had a ton of fun with it with my kids, but it's time for it to find a new home. The giveaway is open internationally, but you will need to cover the shipping cost to anywhere outside of Macedonia. I know that this is a bummer to a lot of you, but this is the best I can do. If you are interested to find out the shipping expenses, then send me your address and email as a message on YouTube and I'll provide you with the estimate cost for delivery. To enter, leave a comment down below and make sure to like my Facebook page. The winner will be announced there on April 4, 2018. Good luck to you all and thank you for watching.